The broadcast is now starting. All attendees are in listen-only mode.
Well, good morning, good afternoon, good evening, wherever you are. I'm just going to show my screen for just a second here to introduce our speaker for today. This is our part of our IFEES GEDC IUC Global Webinar Series, and we have with us a very distinguished speaker representing Phoenix Contact, and that is Mr. Arnold Offner. Is the strategic marketing manager for process automation and infrastructure at Phoenix Contact USA. The topic of his presentation is empowering the all-electric society. Very, very exciting topic indeed for everybody in the world. And as you might have seen from the abstract that we distributed to all of you, about all the some of the details of the content of today's webinar. Our speaker Arnold Offner is a strategic marketing manager for process automation infrastructure at Phoenix Contact USA, with over 30 years of experience in the electrical industry. He's worked on 3 continents for Phoenix Contact in sales, marketing, technical support roles, and a senior member of IEEE, lifelong learner, active in STEM activities. He shares insights with local colleges and schools on the state of the industry, its future trends, author of various articles relating to power supply, interface relay, process automation, industrial control applications. And without wasting any more time, we would like to hand this over to Mr. Arnold Offner. Over to you, Arnold. I'm going to make you the presenter again, and you just have to click show my screen.
Thank you so much. Thank you, Krishna, and welcome everyone. Yes, as Krishna mentioned, the electrical industry was a fascinating one for me. I'll tell you, as a high school kid, I realized very quickly in my choice of career in the electrical industry that it's always the first industry to slow down and the first one to last industry to slow down and the first one to pick up. And so what I wanted to share with you today is a discussion of the all-electric society and how trends within the electric industry, and when I talk about industry, I mean about in business as opposed to consumer products, which is why you'll never see Phoenix in a store. But as customers, our customers are in fact involved in what we call electric infrastructure. And my role in the USA actually involves, as we said, process automation. As you will discover very soon, it's very tightly related to
Arnold, sorry to interrupt. You have to click show my screen again. Something happened. Yeah, okay, keep going. Yeah, you're fine now. Yeah.
There we go. We're good. Okay, set. All right. So empowering the all-electric society, and I wanted to, as I said, get started. There we go. So we'll see how these slides load.
From the bottom of the left screen, you can see that. There you go.
All right. So who is Phoenix Contact? And I wanted to tell you a little bit about us. So Phoenix Contact offers creative solutions in the field of connection technology, electronics, and automation. And we'd like you to join us as we show you the trip that we're going to take on a journey into a smart world. As a background, Phoenix Contact is a privately held company, family-owned, founded in 1923, which means we very soon will be 100 years old. We're very vertically integrated, and I'll explain more about that later. And also, we are very independent. In other words, being privately held means that every bit of profit we generate is invested back into the company. And we do this so that we have the entrepreneurial freedom to make decisions we want, which are longer term, as they relate to industry and where we want to grow as a company. So Phoenix Contact, like I said, was founded in Germany, Essen in North Rhine-Westphalia. I won't go into too much detail about our revenues of 2019, but just to give you an idea, we are 17,000 people worldwide. More than half of them are actually employed outside of Germany, and we have production sites across the globe. And we are represented with 100% wholly owned subsidiaries in 55 or more countries. You'll notice South Africa at the bottom. You'll see Argentina on the bottom left, even as far away as Australia and New Zealand. So I don't know where all our guests have signed in from today, but I'm welcoming you both from the North and the Southern Hemisphere then. Like we said, we are also then involved in what we call our EduNet program. It's the triangle of both colleges and universities and the students the professors at the colleges and the universities, together with the students, and then of course industry. And these are the, this will give you an idea of where some of our EduNet customers are currently located. And we continue every year to then actually expand this into markets where we feel we also want to develop people and develop students in countries where we are growing in our industry. So 140 member colleges and universities right now, as I said, in 34 countries. And this has been a process that's taken part over the course of 20 years. Right. So when I mentioned industry before, I wanted to be very clear. Like I said, as consumers, you and I might not be able to go to a store and pick up a piece that has the Phoenix Contact name on it. But our markets, like I said, are essentially the markets and the industries that work behind the scenes to provide us with everything that we have and everything we enjoy on a day-to-day basis. So originally we started off in what we call energy supply. This is energy generation. We're involved also in the process industry. You'll see a lot of plastic around you. We still need fuel. We still need for your motor car or for your aircraft when we go traveling. We're involved not inside your car, but we are definitely involved in the factory that produced your car. New industries, as I'll mention very shortly, are in the renewable industry, be they wind or solar. Telecommunications, we're not inside your telephone, but we're inside the infrastructure that makes sure that your telephone can communicate with somebody else's cell phone. In the rail industry, both on the train and track side, we're involved in water, wastewater management. We're involved, of course, a lot of these things are done with machines, so we're involved in the machine building industries around the world, which means we're also involved in industrial electronics. That's just an example of one of the electronic modules we make for ourselves. And as we've grown as a company, we also own our own buildings, and so we're also involved in developing our own products for the building automation sphere. So the great success of Phoenix Contact has always been developing the right product at the right time. And our history goes back to 1928, when one of the original founders of our company developed a patent for a DIN rail mounted terminal block. This meant a safe product with reduced space and meant that the electrical industry as we know it today developed very quickly and very broadly globally around the world. And with that, of course, has also come making sure that it happens all at the right time. I guess somebody in PowerPoint must have known that was what I needed right there. So every time needs its answers. And as you will see here, a spectrum of products that have evolved over the years, the decades of Phoenix Contact. I'll draw your attention to the lower row, where we, for instance, show the idea of computers involved in what we call remote I/O, where we show the technology of smaller relays. In other words, the continuing miniaturization of industry has meant we've been able to develop smaller products, saving customers space, in some cases also saving them dramatically in cost. The connector you see there is a development that we pioneered, which is what we call high power DC charging for electric vehicles. Phoenix Contact has for almost 11 years now been involved in that project. In fact, I was fortunate enough to be part of it. And then on the very right-hand lower corner, you'll see a very interesting design. And this is where the future is also headed for those students out there interested in 3D printing. Phoenix Contact has also been an innovator in also even developing its own machinery and technology to provide customers with 3D printing skills. And as you will see there, we have, for instance, one product that shows it in copper. The beauty of 3D printing is you can produce things now in a 3D printer you could never produce by hand or in a machine shop using subtractive manufacturing. So this is just to give you an idea of some of the technologies that Phoenix Contact has been involved in. What it also requires too is, of course, know-how. And what that means is we need to have, and we have, industrial know-how both in connection technology, as I mentioned, the connector, electronics, and then of course automation. And what you see here is an automated production line for control modules that can actually be used. The yellow ones are used in safety applications for machinery. The gray ones, of course, are just regular I/O, and these can be connected then to control systems in any kind of machinery, providing safety both to personnel, to the production line, and also to the product. And this digital know-how that we've then developed internally also means that we develop what we call digital products. Everybody's talking about the digital twin nowadays. We've also developed very interesting digital models, which allow customers to then get product from us, or people to actually get data from us on online. And that also means a change in our mindset. In other words, your working methodologies change as well as your communication. And of course, even though there's COVID at this time, you can still see we're able to communicate with each other because of the digital communication methods that have been evolving over the past few years, that have been very helpful now to keep us up to date and informed about what's going on around the world. That does bring us to the reason why we're here today, and I wanted to pose the three major questions of our time that we need to be aware of. I've kind of showed you already the digitalization that's occurring, and for most of us that have been in the industry for a long time, either in education or in, shall we say, sales and marketing, it's interesting to see how today things like TikTok, things like Facebook, things like Snapchat and Instagram are the way we communicate with each other. Gone are the days of using a postage stamp, gone are the days of sending a letter. These technologies nowadays mean we can get to information instantaneously. We no longer need to go to libraries. We can just simply go to Wikipedia, and we don't have to get a book from a library which might be closed today or closed at this time of day. One of the other challenges we're faced with, of course, and this is of growing concern also to industry and also especially to Phoenix Contact, is climate change and the efforts to reduce CO2, the efforts to basically bring down the temperature increase that we're experiencing every year globally. I can tell you that right now in Hershey, Pennsylvania, it's very hot, it's very humid, and I can imagine that closer to DC, the same thing is happening. And climate change is one of the bigger concerns we definitely have to keep an eye on and also respond to. I wanted to introduce you then to the United Nations Sustainable Development Goals, the SDGs, and one which is most particularly important to Phoenix Contact as we are involved in the electrical industry, and that is the number 7, the affordable clean energy. And I want to share with you some of the things we're doing as a company as well to introduce you to what we're doing and how we're doing our part in that area. So the challenges we're faced with, of course, are there's less and more at the same time. And what I'm trying to say is the compromise, the engineering compromise that one needs to come to when you realize that the world needs more and more energy so that the growing population can live in prosperity and security. But at the same time, we have to have less. In other words, we have to reduce our CO2 emissions to survive. And that means that our pursuit of clean energy will trigger, of course, a huge economic and technological boost. When we, for instance, we talk about the new Green Deal. So unlimited clean energy is possible, and we know it'll be the next driver for the global economy. So what does our vision of the all-electric society include? Well, it's a world with unlimited energy without harmful emissions based on renewable sources. It relies on sustainable growth, which will also then save our natural resources, use them with less waste. It provides a perspective of growth and development for everyone. When I talk about development, I'm also talking about educational development. What this means is we're going to be looking at new techniques and technologies in the coming years that will allow us to actually achieve this goal. And what this ends up being is a balance between the ecological, the economic, and the societal aspects across the globe. And that is what we consider to be the vision of an all-electric society. Of course, one of the first things one does have to look at is the volatility, or as I refer to it, the dependability of renewable energy. We know what time of the day the sun will shine. We also sometimes can tell when wind will come. But of course, we realize that at night that might not be possible. So the sun will of course not shine at night, but the wind energy can come at any time. But one thing is very, very clear, and that is that excess energy can be stored. And technologies that we're looking at right now involve the process of electrolysis, which means the use and the creation of hydrogen, its synthesis with CO2, in fact, using wasted CO2 to create the fuels and chemicals, because hydrogen itself might end up being a very useful energy source for maritime traffic, for aircraft and industry. It might not as much be that one that we will use, shall we say, at home or in our cars, but it definitely will be used in more the higher volume areas, and especially industry as it relates to the aluminum or steel industry. So there are ways and methods to take this excess energy and save it rather than waste it, which is currently what's happening. So we talk about power to hydrogen, power to gas, power to liquid, or as we just commonly refer to as power to X. And X, as I say, can be any energy source that we can use at a later stage. The second thing, of course, one needs to be aware of, and this has come down dramatically, are the costs related to renewable energy. This challenge is particularly interesting because what you will discover is that the reduction in cost in renewable energy has now gotten to the point where this year, and I'm using Germany as an example, wind, onshore wind, and solar has now basically been reduced to the point where it is lower in a cost than the energy mix which involves fossil and nuclear. And of course, 2020 is the year when Germany will turn off all their nuclear power plants. In other parts of the world, not yet. But what you will see is that the cost of renewable energy has fallen so dramatically that the investment in new technology, new energy generating technology, is actually only occurring in areas of wind and solar, also wind offshore, also in the area of hydroelectricity, and in other renewable energy sources as opposed to the fossil mix. And of course, what that brings with it too is the economy of scale. To achieve these economies of scales, we have to think a lot bigger. We have to think about means, and these are done normally in government regulation, either providing people a bonus for doing a certain thing or in the form of taxes. I think of the carbon tax, for instance. But the technological improvements of this economic electrical efficiency is going to require the coupling of these industries with each other. In other words, transport, industry, with infrastructure, with buildings that we live in, and of course, the energy that we're consuming and generating. So our role at Phoenix Contact in empowering the all-electric society is to enable the sector coupling. In other words, the coupling is a balance of, is a holistic approach. Firstly, it involves energy and the data and the functions that can be shared amongst these solutions with each other. It requires the monitoring of energy and the increased energy efficiency, the efficient use of energy. In other words, turning lights off when they're not needed. The balancing of generation and consumption. In other words, finding methods and means that reduces, and then I got to explain this one carefully, reduces the increase that we always see in always making sure that energy is available, even if it goes wasted. And so this balance between generation and consumption can nowadays be done with technology that is Ethernet based, that allows the consuming system to now tell the generating system exactly how much it needs, and to predictively also plan how much is needed in the coming minutes, so that excess energy is not created and then just wasted. And of course, this flexibility occurs too with thanks to energy storage. So the sector coupling needs that exist are, of course, you need smart systems. And as I was mentioning, as it relates to connection, electronics, and automation, that's exactly where Phoenix Contact comes in. So everything firstly is networked. You have electrification, you then have digitalization, which means you have digital information flowing between these systems. And then the automation, which simply means that you and I don't have to go to a light switch every time, or we constantly have to get up and go to a light switch. We rely on automation systems to actually manage all of this information for us. And with that, provide us then with the smart transformation that we speak of. When we talk about industry, you're probably going to find such things, and I'm looking at this now holistically, you're going to find such terms in the industry such as Industry 4.0, or in German Industrie 4.0. You're going to find such activities of China 2025, or here in the US, we commonly refer to the Industrial Internet of Things. So these are some of the terms that fit under the banner of smart industry. In smart energy, of course, we're talking about the energy transition. In Germany, also known as the Energiewende. In other words, it's the transition from fossil-based to renewable energy sources. In Germany, quite cleverly, they rely on offshore wind at the north of Germany. They then rely on solar through the southern half of Germany. And they then, of course, are relying too on renewable energy sources now in a brand new project they've just started that relies on hydrogen energy. And I can see this being a model for a lot of other countries too around the world. We've seen recent announcements in countries like the US and Australia, just to give you a sense of how widespread these techniques and ideas are currently flowing. In smart mobility, of course, we talk about the idea of the electric car, either hydrogen powered or battery powered. We also talk about the idea of developing other means, hybrid techniques for aircraft, which would also reduce the cost and expense of flying and using carbon-based fuels. You've also seen some of the announcements regarding electric engines and electric motors for aircraft. Smart infrastructure, of course, refers to a topic very near and dear to the metropolitan cities across the globe, which is the smart city. The idea that the city can actually also be more efficient in its use of energy in such metropolitan areas as New York City or Shanghai or any other metropolitan, 20 million inhabitants or more city across the globe. And then, of course, smart building. And smart building is an interesting one because smart building currently is one that we see being developed in office complexes, in skyscrapers, and on campuses. This technique, just to let you know, is pretty much also used in a number of universities nowadays. They're starting to develop such things as microgrids. And for an electrical engineer, that's a very interesting idea because your microgrid is simply a combination of all your energy sources and all your energy consumers, and basically automating that so that even a college campus is in a position to be self-sustaining if needed. The smart building is also very interesting because I see this as being something maybe, and sometimes one says it'll take a decade or two, but I see this also being the smart building can also be the smart home or the smart apartment complex. These technologies, as the increasing cost reductions occur in electronics, as increasing miniaturization comes about, and as these techniques develop, we will probably also see the smart home. So for me, smart building can also refer to the creation of a smart home, which can do pretty much the same thing that smart building can do, but only because the technology has now been cost effective enough to deploy it at virtually in every house and household. So these sustainable developments affect all of you. They affect all of us at Phoenix Contact. And so on the way to an intelligent world, we consider Phoenix Contact to be a key partner for these creative solutions in what we term the connection technology, the electronics, as I referred to, and then the automation systems that control them. One of the things that I will allow, and we can discuss later with questions that you may have, are of course how this impacts Phoenix Contact, because it impacts both our customers, those are the customers that buy the product from us, but also the customers that will essentially design our products in, or the students that we either bring on board as new employees in the future, or students that go off to work at other companies, which then use our technologies in developing the solutions that their respective company is developing in this all-electric society. So that is it for Phoenix Contact. The sector coupling that I wanted to give you maybe a graphic representation of, because I know from a day-to-day basis, as you go out and do your regular shopping, you probably don't realize that Phoenix Contact is in the background, is involved in things that might impact your life on a day-to-day basis. The fact that you're able to use, for instance, the internet today wirelessly is in part also because some of the systems that Phoenix Contact has behind the scenes. Now, I don't want to overblow this and say that we're doing all of it. I just want to say that we're developing the components that help many of the customers that are providing their services to you to do this. But as I said, most automotive plants use Phoenix Contact. In e-mobility, we have a global presence already because we were involved in the standards at a very early stage. I still remember Hanover Fair 2009 when we first made our first announcements regarding e-mobility. Solar power, as you should be aware of, is becoming more and more the invested trend. That does have to be distributed, and of course it has to be coupled together with wind energy. The water that you might have gotten from the faucet or the tap this morning when you took a shower or a shave is probably also in the background dependent on Phoenix Contact. The interesting thing most people don't realize is that in wastewater management, those systems fail when the electrics fail. In other words, most of the transmission of water anywhere in the world nowadays is actually done with electricity. And then, of course, building automation and process industry. And I wanted to give you some examples of the, shall we say, the icons that make up where Phoenix Contact product is deployed and is present. Now, the products that we actually make, these components, are various different shapes and sizes. They've relied on mechanical students to design them. In Germany, we talk about Maschinenbau, but in the US market or in English-speaking market, we always refer to a mechanical designer, mechanical engineers, and draftspeople who then design the design to suit the application. We then have electrical engineers, we have software engineers, and we then have a whole host of other sales engineers that take this product to market dependent on what customers are requiring from us. And so this is just a smattering of the 60,000 part numbers we have in our portfolio, all being developed continually to actually satisfy customer needs and to satisfy customer requirements that we discover in the industrial space. There are some very interesting new technologies coming along too that I wanted you to be aware of. Publicly, you've probably heard a lot lately about 5G. 5G is a 5th generation of telecommunication, which means we will have gone through 5 jumps in the space of just 2 decades in technology that would now allow us to download movies in seconds, that would allow us to actually set up industrial campuses with their own Wi-Fi networks so that everything is communicating with everything else. And of course, what 5G allows us to do is to reduce the amount of cabling that's needed to actually do this if you were to do this in a wired fashion. Other technologies we're currently involved with as a company involve TSN. Now that graphic there should show you a RJ45 connector because TSN, or time sensitive networks, are related to the coordination of data on Ethernet networks that I was referring to earlier. TSN is a very important part when we talk about the sector coupling, because all these systems are using Ethernet to communicate with each other in the gigabit range, of course. And so this data has to be coordinated very, very quickly because you do not want to have blips or blackouts or brownouts in your electrical supply system. The IEC 62443 is a safety and security standard that refers to both cybersecurity and functional safety of products. That in turn leads us to the discussion of how cloud and the cloud is now becoming an integral part of how data is shared amongst industries, amongst companies, and also amongst facilities to allow companies that are operating on a global basis to actually get data very, very quickly. OPC UA is a system it's a unified architecture. It's how systems can communicate with each other very, very quickly. And then to our right, we have one last block there that refers to a technology known as single pair Ethernet and APL. Single pair Ethernet is, of course, a 2-wire system with power that allows us in future to send large amounts of data over just 2 wires, making it very simple. APL is designed around the process industry, it too being a 2-wire technology, but also being inherently designed for industrial applications where we also need a technology known as intrinsic safety. And so just to give you an idea, these are the 6 technologies right now that Phoenix Contact is currently investing a lot of its R&D resources in developing new products and new solutions for customers. So the smart world is our focus. It depends on electrification, digitalization, and automation. And so it also relies on the know-how of the industrial world and the know-how of the digital world. And so these are the products that we feel will help empower the all-electric society. There is a very interesting white paper that was published by Price Waterhouse, which refers to the Delphi Energy Future of 2040. And what's becoming very interesting too is that by 2040, the all-electric society is perceived to have become a reality. In fact, I think recent trends actually indicate that this could be done before 2040. But I just wanted to share with you there are some folks that still feel it'll probably happen. More than half believe this thesis will occur by 2040, whereas just less than 38% feel that this might not be before 2040. But I'm very confident that we're going to see this happen. But I was also going to ask you for your thought, because in this manner, we have the chance to do very meaningful things for the development of the all-electric society, for the future of our companies, in your case, for the future of your career, and also for the future of society as a whole. So empowering the electric society also requires the accompanying educational landscape. I wanted to share with you what else we're doing at Phoenix Contact. So in today's presentation, we've discussed what is up top here in the red block, in the green bar. But the next step we would like to also tackle with you are online seminars referred to the 5 sectors that I was referring to. As I was mentioning, we can go into a lot more detail on each and every one of these applications. And so my thought to you was also to bring you up to speed on both the educational relevance and the implication for technical education. All right. So we've covered the first block in today's online seminar. And our topic now arises, how do we tackle the follow-up on these online seminars next? And so what I wanted to share with you, and I'm going to ask Krishna to activate a poll, is to ask you, which of these sectors would you like to know more about next?
Okay, so should I launch the poll? Okay, I'm going to launch the poll. All right, let's see, responses are coming in. Okay, keep coming, guys. We've got almost 170, 80 people here. We need responses from every one of you. Use those fingers wisely and fast. 50% of you have voted. We need a few more. Come in. Keep coming, keep coming. More and more. I'll give you a few more, 15 more seconds. Come on, guys. Some of you are not even touching that button there. Okay, I'm going to stop the poll right now and show you the results. Close the poll, share. I don't know, Arnold, I'll read it out to you in case you're not able to. I'm not sure.
I don't think I'll be able to see it, but a screenshot would be great too then. Thank you.
Okay, yeah, I'll let you know what the smart energy comes up on the top with 46%.
Yes.
Smart industry comes next with 20%.
Okay.
The smart mobility comes up third with 15%.
Okay.
And then 9% for the other two each. Smart infrastructure 9%, smart buildings. So
all right.
Okay, so yeah, screenshot. Sridhar, can you take a screenshot of that and keep it there? We'll put it later on. Send it out to Arnold. Okay, great. Okay.
Yes,
hide that.
Yeah, perfect.
Okay, great. So we are back. and you can continue.
Thank you so very much, Krishna. Yes, so that that information you've just provided us with, your responses help us then to kind of get the sequence right of the next set of presentations we will do to give you more insights into each of those industries, those sectors we refer to. And I wanted to just close by presenting you some of the didactics and educational cooperation methods we actually currently have between industry and, of course, colleges and universities around the globe through our EduNet program. I actually always like to stay on this picture for just a moment to tell you too, the technologies, interestingly enough, that you see here also involve the idea of augmented reality. They also involve the smart intersection, and of course they involve the very interesting ideas that revolve around digitalization and, most importantly, software. Most people don't realize how critical and important software will be as part of this all-electric society. So I always try to interest kids, especially now too in the middle schools and high schools, in the importance of software and understanding, or at least being able to just learn one software package to get started, to understand how machines think, because we're the ones helping them think. So we do have, in the field of technical education, we have, as I introduced earlier, we have the EduNet world, which is of course focused on scientific exchange for teaching in the field of smart production. We then have of course the EduNet, which is our cooperation between Phoenix Contact and partnered universities that have signed up for our program. And then we have also, very interestingly enough, and this is almost coming on now for 10 years now, we've had a whole host of different national and international competition for learners both in the high school, technical college and university levels. And this is also an interesting way for students and for professors to also grade the performance of their students, because I will share with you one thing that changes from the time you go from high school to college is the idea that you're always graded individually at high school and also at college. But the one area that industry is always keen to look at is how well do you work in a team. And teamwork, of course, I always tell people engineering is a team sport, probably one of the most important ones, because it doesn't stop. It doesn't have a season. It doesn't start in the winter and end in the fall. It is a year-round experience. And so, like I said, Phoenix Contact is involved in a whole host of different educational associations. And I'd also like to say thank you yet again to IFEES for today's opportunity. If you would like more information about the didactics activities we have, I do want to draw your attention to this particular email address, didactics@phoenixcontact.com. We have a team based in our headquarters in Germany that is involved in actually coordinating these efforts then with our subsidiaries around the world. And so I do just want to bring your attention to didactics@phoenixcontact.com. All right. With that, I'm going to then just mention and give you some ideas about how this works in the future. You'll notice this is also a very different kind of a slide, but it shows the implementation of international networks, which of course are essential for the shaping of our common future. The product that I'm actually showing here is a very interesting new product that we've launched in the past few years now, which is slowly starting to get a lot of traction in industry. It's a product known as the PLC Next. And what it is an open sourced software controller-based platform, which we are now developing further for these industries that I show here. So industrial networks, and of course that's the other schemes we have, is the industrial Ethernet switching and all the other relevant technology that goes with it. All right, with that I want to say thank you. I want to open up the floor to any questions you may have, any comments you may have. Krishna, I guess this is where you get
absolutely, yes, Arnav. This has been such a terrific presentation. I'm so excited about it. And this whole vision of all electric society, I think it's exciting to our students, our faculty members, our friends from industry, and the fact that Phoenix Contact is so dedicated to this vision is we're very lucky to have you with us and to share your technology and your information with us. We have a couple of people that I pulled out into the panel. Maybe give them a chance to talk initially if they would like to. And then we have several people from the audience that are sending us text messages that we will definitely get to as many of them as possible. So thank you very much. I don't know if Sam would like to chat. Sam and Allah, would you like to chat a little bit? Sam and Allah, I put you
yes,
come in, Sam.
Yes, this is Sam Mokasa. Thank you very much for that presentation, Arnold. Very, very informative, and in fact, very relevant to a conversation we started having yesterday with engineering deans all over the continent of Africa, where energy issues are already quite acute, and I think they're going to get even more interesting to discuss going forward. The concept of microgrids is one that came up, and I think is going to be extremely important on the entire continent. My question to you, I think, would be, you've provided us with the email address to contact you about Didactics, but I'm wondering whether you have any specific comments to make about outreach, educational outreach programs, particularly in the developing world, where I think that if we're going to address climate change and fossil fuel consumption and so on, that's where population growth is going to be the greatest, and therefore the need is going to be greatest there. Do you have any specific didactic or outreach programs toward that part of the globe?
You know, not right now, but I think I'd also rely on my colleague Klaus Hengsbach in Germany to maybe provide some insight into how we would actually tackle, because you're actually bringing up the area of the world that I feel as a continent is most in need of microgrids, and is actually going to have to take a leap from no energy to what I call the renewable energy start. And I've seen it already in Africa, where, for instance, the idea of cellular technology, that jump did not occur from landlines, which is how it happened here in other parts of the world. And so I see in Africa, particularly, the jump immediately into renewable energy sources, be they wind, be they solar. Solar most particularly because what most people don't realize is that the central part of Africa, and I'm talking really a part where the equator is probably the most valuable area where one could generate a lot of energy from. But I think maybe Klaus might be able to provide some insight into what we currently are thinking about or working on. I'm not aware right now of a specific Phoenix Contact program, but I can tell you here in Harrisburg, where I'm based, we actually have a number of students that have come on board at Phoenix Contact in the past 2 or 3 years that have been involved through their colleges in actually providing and traveling to Africa to actually fully understand what's needed. Because of course, now that everybody has a cell phone, that's one of the first devices that also needs electric power. Once you have electric power, you can also get clean water, which is one of the other sustainable development goals of the United Nations. So you can see how each of these events then becomes another link in a chain that helps us to actually get everybody to clean energy and the benefits of clean energy.
Yeah, indeed. You know, this is a subject I'll be very interested in pursuing further, even after this seminar is over, because again, to your point, you know, devices like cell phones need power, but even more importantly, I would say you need reliable power to be able to run effectively in places such as hospitals and university campuses and so on, or even manufacturing for that matter. You have an assembly line that's making, you know, certain gadgets and so on. You have to have a reliable source of electricity. And in many countries today, the power will be on for a few hours and then unpredictably go off. You could be in the middle of some very important process and then it just disappears.
Yes.
So let me get to Klaus. Klaus might have some comments here. Klaus, come in.
Yeah, I will give a comment from my side. Thanks for your interest to discuss further topics. At the moment, we are currently discussing projects for the African country with our government. because the German government especially is interested to set up initiatives for qualification in whole Africa. And therefore we are at the moment oriented in the northern part of Africa, but we have also close relation to, for example, Cape Town University, and we need so the requests and the requirements from the universities and institutes from Africa that they are interested to cooperate with, let's say, a consortium from IFEES Contact and other companies from Germany. So we are highly interested to get in touch with you, and please let us discuss later bilateral in the coming days about some ideas how we can go ahead in this field. And so, all electric society could be also a bridge to closer cooperation. Very good.
Sounds good. Thank you.
Thank you. Thank you, Klaus. Thank you, Sam, for your excellent question. Ala, would you like to have any comments, or should I go to the audience? Go ahead, Ala.
I'm fascinated by the presentation. It's very informative, and you know, just brings the whole spectrum of new technologies that are gonna be changing our lives. But it looks like a lot of it is already happening now. I was just intrigued by the cut down in cost of alternative of solar and wind in Germany, to the extent that now it's almost at the same cost as or the same price as fossil fuel, which I do find intriguing. Maybe if you could comment on this, and how that was, you know, how did we reach that point? Because that could impact a lot of other countries that are looking at you know, at this problem.
Yes. Ala, if that question was directed at me, I can tell you too that in the USA, for instance, the financial people who look at a 10 to 15 year return on their investment, for instance, in gas-powered turbine projects, are currently revisiting the idea of going now to renewable energy sources. In other words, they don't see a future in 10 years for gas-powered turbines as an energy source. So they have actually started to see the writing on the wall that this ongoing trend in the reduction and the electronic cost of producing a solar panel, and also the increasing sizes and efficiencies of wind turbines, now means that your renewable energy sources, in fact, not just in Germany, but also in the US, are now at the point where long-term or short-term, medium-term investment in those technologies of carbon-based fuels, fossil-based, they're no longer worth it. In other words, all their money now is being thrown at solar and wind. Okay, thank you. I'm going to go to the questions from the audience. Multiple questions here from you. For one of your charts, you know, has this transition for the cost over a period of time, and in 2020 you showed that's where the cost of you know, wind and solar will be at the same level as fossil electricity. So our question is, does that include the cost of storage and reserve margin needed? No, that's just the generating cost, because when you do either a fossil-based or you do a renewable energy and you store them in other ways, that is not brought into this conversation. But really what we wanted to show is how this trend has now gotten to the point where the idea of saying renewable energy doesn't make sense, that threshold, for instance, in Germany has now transitioned. And you have to realize too, in Germany, which is very interesting, they already have very high energy costs, both because they are providing money to the coal industry to keep coal miner jobs, and at the same time, the high import duties mean that, you know, if you're in relative terms, all these factors built into that equation now show that the trend is definitely favoring renewable energy sources into the future. Okay. Another question from India, from Papula. What is the impact of quantum computing in the industry? That I didn't go into because it's not a technology we're looking at, but it's one some of us are keeping an eye on. that as a compute. So just for anybody else who's interested in this idea, Moore's law is actually the law that keeps telling us that every 18 months a technology and the data storage will be halved in space. In other words, your cell phone of today has more processing power than the entire infrastructure needed to send a man to the moon in 1969. And what you're dealing with now is quantum computing is the next stage in how we're also going to make microprocessors that can do things at incredible speeds. And of course, quantum also means that they're going to be able to process a lot of data. And we don't bring it as such into our conversation simply because of our product portfolio, but it's probably going to impact our industry more than we know in the coming years.
Okay, thank you. Question from India again. As you see, many of our participants are from India and other parts of the world.
Fantastic.
Any plans for EduNet to expand to the Indian academia, and any chances that some Indian engineering students can get internships with Phoenix? This is Manish Kumar Pandit, who's an industry expert in India.
So I will pass that one on to Klaus and to Jenny, because they actually just recently returned from a trip to India, because India is one of the markets currently where we are actually investing a little more effort at present. So Klaus or Jenny?
Jenny, go ahead.
Yeah, thank you. Hello, everybody. Yeah, it is my pleasure to report you that we are already in discussions with universities from India. Of course, it is highly interesting. It is a really huge country. It is full of smart people and on proper universities, which we would love to work with. And we are already in discussions with educational institutes and ongoing.
Okay, great. Question from Alvin White. Do you work with social scientists to consider the human implications of an electric society?
Actually, we are used to work in interdisciplinary teams. And so at Phoenix Contact, not only engineers and technician occupation persons are working on the strategy and the implementation of all electric society. Actually, it is a close cooperation between social disciplines and techniques. And if you think on communication, on implementation of innovations, you really need psychologists and people like that.
Okay. Here's a question from Gabriel Bolliger. It's in German though, and I don't speak German, but I'll read it out the way it has been written. If Hans was been there, would have done a better job. It says, Gibt es online Trainings für Studenten bezüglich den PCL next?
Okay. Please allow me to answer in German. Hallo Gabriel, wir arbeiten im Moment daran und es gibt auch zu PSC Next Trainings online. Bitte schreib mir an die Didactics at Phoenix Contact eine E-Mail und ich werde dir die Links dazu zuschicken. Okay, that was it. That was German.
Maybe you can give that answer in English again so that other people can also understand that.
Please, we spread it already, our email address. If you have any demands, any requests, any notes, any recommendation, please use that email address to contact us. And of course, it would be my pleasure to send you links for trainings regarding certain Phoenix Contact technology.
Okay, great, thank you. Several participants were, you had 5 options, and in the poll, many of them wanted to give more than one option. So, in fact, many people are interested in organizing seminars on all 5 topics. So, just want to let you know that.
Yeah, I think then, if you don't mind, use the Didactics poll and use the Didactics at Phoenix Contact email address. We could send to the participants that poll again, right?
Mm-hmm. Yeah, absolutely.
And just let them, if there's multiple choices, by all means, yes, rank them. Then rank them as 1 as being most important and 5 being least important.
Right.
You can use that as a scaling factor.
Excellent. Question from Johan Nicolaides. Is it possible to use hydrogen in the automobile industry by redesigning the auto motors in the future?
So the answer is yes. And the reason why I do it with a little trepidation is because I feel there's two trains of thought right now. The hydrogen industry is currently looking at the larger volume users, the trucks, the buses, the ships, as a platform for its what we would call electric transformation. If you look at hydrogen in a motor vehicle, you have to consider that right now it's very, very inexpensive, because you would need a lot of infrastructure around to recharge the hydrogen into your vehicle. This is not something you can do very easily at home just yet. This is something that you could only do in an industrial setting. And so the modification of a car to run on hydrogen, it is possible, but I'm not yet sure that it's going to be a reliable technique to get around. But we'll see how that changes in the industry. In fact, when we discuss, yeah.
Question from Glenn Williams about e-bike. Okay, says the PX focus, will it focus on e-bike, such as charging infrastructure as a subsector in e-mobility?
So if you look at, for instance, and I talk about Glenn, I talk about the brand new Harley-Davidson Livewire. It's a project we've been involved with since Harley-Davidson first announced it. They are using the very same connector on the motorcycle that they do on in electric cars, because you use that charging infrastructure to travel distances of 100 miles or 100 plus miles or more. When you look at e-bikes or the electric bike, that technology is normally programmed or charged through what I would call the home outlet or the outlet at work. So it's not necessarily going to need a fancy connector, a reliable connector. It's going to be it's more a household type product. Hope that answers the question.
Great. Felipe, is there, Felipe Mateos, is there PXC considering some innovative special actions over the world about the pandemic crisis?
So as a company, we're a component manufacturer, and we've actually been considered in many countries where we are still active in our production and our logistics as essential. A lot of our products flow into such things as ventilators. They are used in these robots now that are using to use UV light to clean and to eradicate the virus in rooms that are not occupied by people, because that's a technology that actually has existed for many years now. It was created when the MERS first arose. Phoenix Contact's support of industry has also been, just to let you know, the power, the energy. We've had a number of customers come to us and require us to keep supplying them with product, so that the inherent infrastructure, what I'd say almost the backbone of the electric grid, remains in play. Maybe Klaus and maybe Jenny has more insight into it from a Germany perspective, but I think that's kind of where Phoenix Contact has been involved in Corona. So a lot of our office staff has been relocated to working from home, and our production and logistics people in our various facilities around the world continue to work with safety measures, with masks, with hoods, to produce product for customers to ensure that the electric grid and all its associated equipment still keeps running.
Okay, thank you. Hans will conclude the session in just a few seconds. I'm going to ask one quick question from Deepak Waikar from Singapore. Yes. Do you think all electric world, is it possible without nuclear energy?
Yes.
Okay.
I'll say yes, because I think one needs to realize nuclear energy, the philosophy of nuclear energy, and when I say it can be done without nuclear, I mean it, but I also mean that nuclear energy is maybe going to go through an evolution. Nuclear energy has always been what we call bulk power. In other words, it's been the base load. In future, we're probably going to see nuclear energy become almost like a battery that you can use when you need to. And so the nuclear industry is already looking at techniques where they would actually provide either the thermal energy they create or the electric energy they create in a hybrid fashion. And you might actually in future see smaller nuclear plants They refer to these as small nuclear units that will actually provide power when the sun's not shining, or they will be supporting a wind farm when the wind is not blowing. But yes,
Okay.
that's the two-part answer to that question.
Okay, so we'll give Hans a chance, and Jenny and Klaus, if they want to wind up. Go ahead, Hans, up to you.
Yeah, thank you. Thank you very much, Klaus and Jenny. I deeply appreciate you facilitating the presence and presentation by Arnold. I found him to be one of the most effective presenters that we've had in our very successful webinar series. Arnold, you have a gift for communication that I think is very, very effective. Let me just make a couple of comments here. And I want to continue those discussions at some other time. I like the idea for us to explore, Klaus, some other seminars. I think some of the topics that were mentioned here is definitely worthwhile to explore. And our partnership that brings win-win to all of us, I'd like to see that. Number two, your interest to work with the German government in Africa is of fundamental strategic importance to both IFEES and the GEDC. And the fact that you have connections in South Africa, obviously through Arnold and his life, but we work closely. Our global conference this year in November, I want to very much see, your engagement and connecting with universities in that part of the world. And as Sam said earlier, we're in close discussions, having helped create the African Deans Council. There are issues that I know where we can find win-win for all of us moving forward. Finally, in addition to just raising your awareness of our global November conference, of all of you who are here in this large audience today, I'd like you to take a look at the IFEES website, and we are in discussions currently in something we call Project ECHO, which brings medicine and engineering together through the concept of peace engineering. We don't have time to talk about that today, but look at the website and we can stay in touch with that. Again, Arnold, very excellent presentation. We deeply value it. Thank you.
Vielen Dank. Gern geschehen.
Yeah.
Welcome.
Thank you so much.
Jenny and Klaus, any last comments?
No, we are so satisfied, more than that.
Okay.
And of course,
Okay.
it
And thank you,
was
everybody.
We are
excellent.
pleased about all the interesting questions, and hopefully we stay in contact and can go deeper into some topics. And yes, thank you for interest.
Thank you,
Thank you,
everybody,
everyone.
and stay healthy, stay happy, stay safe. Okay. Goodbye.
Stay healthy
Okay.
and healthy.
Auf Wiedersehen.
Have a good
Tschüss.
day.
Tschüss. Bye. Thank you.
Bye-bye, everybody.